In this video, we will look at trigonometric ratios of quadrantal angles. Now consider a unit circle. When I say unit circle, it's a circle with radius equal to 1 unit. So your R is equal to 1. So this is the center of the circle and this is the radius. This R is equal to 1. Now this line, it can rotate around the circle, and as this line rotates around the circle, an angle theta will be formed between this initial point and to the terminal point. So this angle here, we are considering it to be theta, which starts from the x-axis here on the positive side and all the way to here. So if I rotate it further here, this will be 90 degrees. So this part of the graph is called the first quadrant, and from 90 to 180 degrees is called second quadrant, and 180 to 270 is called the third quadrant, and 270 to 360 is called the fourth quadrant. So full circle is 360 degrees. Now from this point where this line touches the circle, the length is equal to 1. Let's draw a line which is perpendicular to the x-axis. When we do that, the angle here will be 90 degrees. Then this will become a right angled triangle. So in this right angled triangle, the length here is x equal to x, and this height here is equal to the height of the y-axis, so that is y. And this is your hypotenuse of the triangle. And this we have estimated it to be R is equal to 1. So you can define this coordinate here as x comma y, which is a point on the circle. Now if we take this right angle triangle and define sine theta, then our sine theta will be equal to the opposite side divided by hypotenuse, which will be y divided by r. Similarly, if I define cos theta, then cos theta would be adjacent side by the hypotenuse. So that will be cos theta equals to x by r. Since our r is equal to 1, substituting 1 for r, we will find our sin theta is equal to y by 1, that's equal to y, and our cos theta is equal to x by 1, that's equal to x. Now further we can extend this coordinate as cos theta comma sin theta, because our x is equal to cos theta, y is equal to sin theta. So we define this coordinate as cos theta comma sin theta. Extending this concept, I can now define every point on the circle as cos theta comma sin theta. As the value of theta changes, I will keep replacing that value here and I will keep rotating. For example, if I define this point here, this angle is 90 degrees. So this coordinate here will be cos 90 comma sin 90, and this coordinate will be cos 180 comma sin 180. Similarly, cos 270 sin 270. If we make a full circle, this can be also defined as cos 360 comma sin 360. So let's look at this. So I have defined this point here. This point is nothing but, since it's a unit circle, on the y-axis it is 1, so this is 1 here, and in the x-axis the value is 0, so it is 0 comma 1. That's this coordinate here. But we said that we're going to define it as 90 degrees, which is cos 90 degrees comma sin 90 degrees. Therefore, my cos 90 degree is equal to 0, sin 90 degree is equal to 1. And you can see that here. Cos 90 is equal to 0, sin 90 is equal to 1. Similarly, if we go to this point here, the angle is 180 degrees. So I'm going to define this point as cos 180 degrees comma sin 180 degrees. Now cos 180 degree is nothing but minus 1. because this coordinate here is in the x-axis minus 1 and in the y-axis it is 0. So minus 1, 0. Hence, this will be defined as cos 180 is equal to minus 1, sin 180 is equal to 0. Similarly, applying the same concept here to the 270 degrees, your coordinate will be 0, minus 1. And so your cos 270 will be 0, sin 270 will be minus 1. Similarly, cos 360 will be 1 and sin 360 will be 0. And this is also 0 degrees. So cos 0 will be also equal to 1 and sin 0 degree will be equal to 0. We're going to extend this definition to allied angles. So when I say allied angles, I'm replacing the theta with 90 minus theta, which is I'm associating this angle with respect to this 90 degrees here. All of these are in degree measure. So consider this as 90 degrees. So let us define this point as an angle which is 90 degrees minus theta. So this is theta. So 90 degrees minus theta, which is this is the angle that we're talking about actually, which is 90 minus theta. Therefore, this will also be theta here. So if this is our coordinate cos 90 minus theta, sin 90 minus theta. So what we will do is, let us consider this right angle triangle here right now. And let's define what will be sin theta for this. So your sin theta here will be opposite side, which is x, divided by your hypotenuse, which is 1. So its answer is x. Sin theta will be equal to x. Therefore, we have already seen that cos 90 minus theta is your x coordinate here. So this is equal to x. So replacing this value into this, you get cos 90 minus theta is equal to sin theta. Similarly, let's do cos theta is equal to, cos theta for this triangle will be equal to adjacent side, which is y, divided by 1, which is the hypotenuse. So which is y by 1, and that's equal to y. And we have already defined this point, the y coordinate, as sin 90 minus theta. So our y will be equal to sin 90 minus theta. Therefore, sin 90 minus theta is equal to cos theta. Now let's look at what will be tan 90 minus theta, and that's equal to sin 90 minus theta divided by cos 90 minus theta, which is substituting the values for sin and cos from here. Sin 90 minus theta is cos theta, so let's replace that, and cos 90 minus theta is sin theta. Replacing them, you get cos by sin. Cos by sin theta is nothing but cot theta. Therefore, the values of the allied angle 90 minus theta for sin would be cos theta, and for cos would be sin theta, and for tan would be cot theta. Let's consider the next allied angle, 90 plus theta. Okay, so when I say 90 plus theta, this angle here is theta. So 90 degrees plus theta. So this is the coordinate on the circle. So this coordinate on the circle would be defined as cos 90 plus theta, sin 90 plus theta, which is, we know that the coordinate here has a negative value for x and a positive value for y, because in the second quadrant the x value is negative, the y value is positive, so it's minus x and y. So I'm going to define my cos 90 plus theta as minus x and sin 90 plus theta as y. Now let's consider this right angle triangle here. So in this right angle triangle, what will be my sin theta? My sin theta would be equal to x by 1. So sin theta will be equal to x. So we know that our x is nothing but, or minus x is cos 90 plus theta. So I'm going to replace this x with sin theta. So my new cos 90 plus theta will be equal to, which is minus x, and the x is sin theta, so it becomes minus sin theta. So my cos 90 plus theta is equal to minus sin theta. Similarly, if I find the cos theta, it will be y, and my sine 90 plus theta is equal to y, which is same as cos theta. So sine 90 plus theta is equal to cos theta. Extending it to tan, you have tan 90 plus theta is equal to sine 90 plus theta divided by cos 90 plus theta, which is replacing the values here, you get minus cot theta. And this would be our table for sine, cos and tan for 90 plus theta. Next allied angle that we will look at is 180 minus theta. So my angle from the initial point is 180 minus theta. So this angle here would be theta. So the coordinate for this point on the circle is cos 180 minus theta, comma sine 180 minus theta. And we know that the x coordinate is negative value and y is positive. So my cos 180 minus theta is equal to minus x. Have it here. Sine 180 minus theta is equal to y, and you have it here. Further, applying on this triangle, sine theta would be equal to opposite side, which is y divided by the hypotenuse 1. So that's y. So we know that sine 180 minus theta is equal to y. Therefore, equating the two, we get sine 180 minus theta is equal to sine theta. Similarly, cos theta for this triangle would be x. And bringing this down here and replacing this x with cos theta, your answer would be cos 180 minus theta is equal to minus cos theta. Extending it to tan, you would get it as minus tan theta. And that's our summarized table for 180 minus theta. We have a few more allied angles. We'll quickly go through them all. The next allied angle that we will look at is 180 degrees plus theta. Okay, and we know this coordinate will be negative for both x and y axis on the third quadrant. So my cos 180 plus theta will be minus x, sine 180 plus theta will be minus y. I have it here. Further, considering this triangle, right angle triangle, and finding sine theta, you will get it as y. Applying it onto this, what we have here as sine 180 plus theta, you get sine 180 plus theta is equal to minus sine theta. Similarly, cos theta for this triangle would be x. And extending this result onto this, you get cos 180 plus theta is equal to minus cos theta. Further, extending the result to tan 180 plus theta, you will get your value as tan theta. And that's our summarized table for the 180 plus theta. The next angle that we would look at is 270 minus theta. Again, for this angle, the coordinates here is both negative, minus x and minus y. So my cos 270 minus theta is equal to minus x, and sine 270 minus theta is equal to minus y. Then again, considering this triangle, this angle here is theta. Therefore, my sine theta will be equal to x. Replacing the value of x onto cos 270 minus theta, we will get cos 270 minus theta is equal to minus x, and x is equal to sine theta. So this is equal to minus sine theta. Similarly, cos theta for this right angle triangle would be y. And applying this onto this, you will find your sine 270 minus theta is equal to minus cos theta. Extending it to tan theta, your tan 270 minus theta would be equal to cot theta. And that's a summarized table for 270 minus theta. Further, extending it to 270 plus theta. And our x coordinate here is positive, it's on the positive side. And the y coordinate is negative, it's on the negative side. So it's x minus y. So my cos 270 plus theta is equal to x, and sine 270 plus theta is equal to minus y. This is the coordinate here. Further, taking this right angle triangle with angle theta here, you will find your sine theta is equal to x by 1, which is x. And let's apply this value of x, which is x is equal to sine theta, onto this equation here, which is cos 270 plus theta is equal to x. So it becomes sine theta. Further, applying cos theta onto this triangle, you find cos theta is equal to y. And extending this result onto this equation, you will find sine 270 plus theta is equal to minus y, and y is cos theta, so it becomes minus cos theta. Further, you can extend this result to tan 270 plus theta, which becomes minus cot theta. So that's our summarized table for the 270 plus theta. Then the last angle that we would look at is the negative angle, which is minus theta, which is from here to here. It is theta. Since it's on the opposite direction, this will be minus theta. However, your coordinate here would be x, comma, minus y. And also applying this, we will have this as cos minus theta and sine minus theta. So our new cos minus theta is equal to x, and our sine minus theta is equal to minus y. Again, considering this triangle, right angle triangle with an angle theta, and finding sine theta, you will find it as equal to y. So let's extend this result, which is y is equal to sine theta, into this equation. So you will get sine minus theta is equal to minus sine theta. Similarly, you will find cos minus theta is equal to cos theta, and your tan minus theta will be equal to minus tan theta. That's our summarized table for the minus theta. Okay, now let's try and summarize our results. So 90 minus theta will be in the first quadrant. So I have put this table here, and 90 plus theta will be in the second quadrant. I put this table here, and similarly 180 minus theta is in the second quadrant, and 180 plus theta is in the third quadrant. 270 minus theta is in the third quadrant, and 270 plus theta is in the fourth quadrant, and also minus theta is in the fourth quadrant. Now, a noticeable thing that you can find here is, in the first quadrant, our sine, cos and tan are all positive. So you say all are positive in the first quadrant. In the second quadrant, you will find that both the cos and tan are negative values, whereas sine theta is a positive value. So sine theta is positive in the second quadrant, whereas the other two are negative. Similarly, on the third quadrant, you will find tan is positive, whereas sine and cos are negative. And on the fourth quadrant, you will find that cos is positive, whereas sine and tan are negative. Now, on the radian measure, we have an extended table here explaining. Now, what we have done is, on this table, you will find that, you can find that some of the sine becomes cos, and here the sine is the sine. So this table summarizes or, segregates all the sine together, wherever sine becomes sine, except the positive and the negative sign. And on this side, we have wherever sine becomes cos. Of course, here it is negative and negative. So this is a consolidated table for your reference. It's important to get this table by heart so that you can apply these formulae wherever required in the trigonometry. A further consolidated table for your reference of the allied angles. Let's move on to do the example problems from chapter 3. So example 3.8. The terminal side of an angle theta in standard position passes through the point 3 minus 4. Find the 6 trigonometric function values at an angle theta. So what was given to us is the point 3 minus 4. So let b xy be equal to b3 minus 4. So we have that here. We know that minus 4 and b, or b and minus 4, will be in the fourth quadrant. Now OA be the initial side. So let's define this OA as the initial side with O as the center, and OB be the terminal side. So OB is the terminal side of the angle theta. This is the angle theta in the standard position. then the angle AOB is the angle theta, and theta lies in the fourth quadrant. So this angle lies in the fourth quadrant. Okay. Now we can consider this as a right angle triangle, which is OA and B, and we can find R as the hypotenuse. Since we know the points are 3 and minus 4, R will be equal to, this length is 3, this length is minus 4. So 3 squared plus 4 squared. So you will get your R as equal to 5. So now you have your x coordinate 3 and your y, which is minus 4, and your R length is 5. So let's proceed to find all the trigonometric ratios. So sine theta would be equal to, from this, y by r, which is minus 4 by 5. Y is equal to minus 4 and your r is 5. So it's minus 4 by 5. Similarly, cos theta will be x by r, which is 3 by 5. Tan theta will be y by x, which will be minus 4 by 3. Similarly, our cosec theta will be r by y, which is minus 5 by 4. And secant theta will be r by x, which is 5 by 3. And cot theta will be x by y, and that's equal to minus 3 by 4. Example 3.9. If sine theta is equal to 3 by 5 and the angle theta is in the second quadrant, then find the values of other 5 trigonometric functions. To solve this, we know that sine square theta plus cos square theta is equal to 1. Therefore, we can say that cos theta is equal to nothing but plus or minus square root of 1 minus sine squared theta. Since we are given the value of sine theta, let's replace it here. So this becomes plus or minus square root of 1 minus 3 squared by 5 squared will be 9 by 25. Simplifying this, you'll get the answer as plus or minus 4 by 5. So cos theta is equal to minus 4 by 5, as cos theta is negative in the second quadrant, because it's given here, it's in the second quadrant. Now we have found cos theta and sin theta. So further applying it, using sin theta, we can say our cosec theta, which is nothing but 1 by sin theta, or the reciprocal of sin theta, would be 5 by 3. Similarly, cos theta is minus 4 by 5. So secant theta, which is the reciprocal of cos theta, would be minus of 5 by 4. Tan theta is sin by cos, which is equal to minus 3 by 4. And cot theta is equal to 1 by tan theta. So that would be 4 by 3 with a minus sign. Example 3.10. Find the values of, first question, sine minus 45, second cos minus 45, and cot minus 45. We know that sine minus theta, if it is in the fourth quadrant, will be equal to minus sine theta, and cos minus theta, if it is in the fourth quadrant, will be equal to cos theta. Cos will be positive, and tan minus theta will be equal to minus tan theta if it's in the fourth quadrant. Similarly, cot minus theta will also be equal to minus cot theta. So let's apply that onto this problem. So sine minus 45 degrees will be equal to minus of sine 45 degrees using this formula. So sine 45 degrees is 1 by root 2. So it's minus 1 by root 2. Second is cos minus 45. So we know that cos minus theta will be cos theta in the fourth quadrant. So extending this, so this becomes cos theta, cos 45, and cos 45 is 1 by root 2. Similarly, the last one, which is cot minus 45 degrees, will be equal to cot 45 degree minus cot 45 degree, and that will be minus 1. Example 3.11. Find the value of sine 150 degrees, cos 135 degrees, and tan 120 degrees. Now you see, sine 150 degree can be rewritten as sine 180 minus 30 degrees. So let's see how we can do that. So we can either write it as 180 minus 30, or it can also be written as 90 plus 60 degrees. So sine 90 plus theta will be equal to cos theta. So using that formula, we have sine 90 plus 60 will be equal to cos 60, and cos 60 is 1 by 2. If we consider 180 minus theta, then sine 180 minus theta is equal to sine theta. So 180 minus 30 degrees will become sine 30 degrees. Again, sine 30 is 1 by 2. Next problem, which is cos 135. So we can write cos 135 as 90 plus 45. So cos 90 plus theta is minus sine theta. So minus sine 45 degrees. So 45 degrees is 1 by root 2. Your answer will be minus 1 by root 2. Alternatively, you can also do cos 35 as 180 minus 45 degrees. So 180 minus theta of cos would be minus cos theta. So which is minus cos 45 degrees here, and that's equal to minus 1 by root 2. Now the third one, which is tan 120 degrees, can be written as tan 180 minus 60 degrees, which is nothing but minus tan 60, which is minus root 3. Or you can also rewrite tan 120 as 90 plus 30, and you will get the same answer. Example 3.12. Find the value of sine 765 degrees. So let's rewrite 765 as 2 times 360 plus 45. 2 times 360 is 2 full rounds in the circle. So plus 45 degree will be sine 45 degrees, which is equal to sine 45 is 1 by root 2. Similarly, we can apply the same technique for cosecant minus 1410, and your answer would be cosecant 30 degrees, which is equal to 2. And for cot minus 15 pi by 4, your answer would be solving this using the same method as 1. Example 3.13. Prove that tan 315 degrees cot minus 405 degrees plus cot 495 into tan minus 585 is equal to 2. So let's take tan 315. Tan 315 can be written as 360 minus 45 degrees, and our cot minus 405 can be written as minus cot 360 plus 45 degrees, and our cot 495 can be written as cot 360 plus 135 degrees, and our tan minus 585 can be written as minus tan of 360 plus 225 degrees. Applying the respective values, this is nothing but minus tan 45, and this is minus 45 cot 45, and this is nothing but minus tan 45 degrees, and this will be minus tan 45 degrees. So applying the corresponding values, you will get minus 1 into minus 1 plus minus 1 into minus 1. The answer would be 1 plus 1, which is 2.
Thank you for watching Maths Tutorial Anand. Please like, and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.